good afternoon all. Am I audible?
Yes, ma'am.
So, in the last lecture, we have seen uh, chapter number 4 that we have started. Last two lectures, we have covered some of the protocols as like aloha, slotted aloha, some of the basic strategies related with that protocol. Also, we have covered the CSMA and collision free protocols. So in last lecture, I have taken the review of all the points that we have covered. So let's see what is the next part. So we have seen this part also, collision-free protocols. Okay, so whatever protocols we have seen before to the collision-free protocols, that we call it as, for example, contention-related protocol, where collision is possible. Okay, when the number of stations tries to acquire the same channel at the same time, so collision may occur. So some protocols are required where the collision cannot occur or it can be avoided. So these protocols comes under the strategic collision free protocols, and uh, uh, these are the two collision free protocols that are nothing but the bitmap protocol and binary countdown protocol. Okay, so these two protocols we have already seen. So quickly, I'll show you what is meant by the bitmap protocol. So in bitmap protocol, see main intention in this type of protocol, that is collision free protocol, is what? Just to avoid the collision, right? So though it is in the contention slot, contention period means what? Where collision can occur as well as frames can be allocated. So such period is called as a contention period. Okay, now how the bitmap protocol works, see here. So suppose these are the contention slots 0 to 7. All these are the contention slots. So in case of the bitmap protocol, the station, those who want to send the frame, they just transfers one bit in their contention slot. For example, station number 1 want to send the frame. So what it will transfer? It will transfer one bit in its slot. Station number 3 wants to transfer, it will send one bit in its slot. Likewise, the station who want to send the frame or the data, they just transfer one bit in its slot. Now, after completion of all the stations of transmission of the one bit in their own slot, the frames are transmitted in a order. Okay, so in a numerical order we can say, so first station number 1 will transfer, then station number 3 will transfer, and then the station number 7 will transfer. Okay, so the station, those who want to send, they must have to wait for this particular slot. Once the slot is over, that station is not allowed to send the frame. Okay, so in this way, as every station is having its own slot, प्रत्येकाला काय स्वतःचा एक slot आहे to send the frame. So there is no thing, or there is no chance of the collision, because everyone is using their own slot, so no one will interfere in any other slot. So that is how the collision can be avoided. So this is one protocol, and the second one is the binary countdown protocol. So in case of the bitmap protocol, the major disadvantage is that here it has, or the working is rely on one bit message only, or one bit frame. So this is quite difficult. So instead of one bit, the next protocol is the binary countdown protocol, where this protocol works on the addresses. Okay, working of is depend upon the address of each station, which is given like here. Suppose there are four stations, 0 1 2 3. These are the four stations. So how binary countdown protocol works? So they just send their addresses like this. Okay, those who want to send the frame, what they does, they just send the addresses, and once every station completes their sending of the address, they a bit operation is performed on address of the each station. Okay, so first bit is taken, so 0011 and 1. So which, how this result has come, which logical operation we have performed here? Can anybody tell which logical operation is performed on this? Yes, OR operation. Correct. So Boolean OR operation is performed on this bit and the result is calculated. So while calculating the result, each station observes the bit of every other station. प्रत्येक स्टेशन काय करतं तर ऍड्रेसचा बिट ऑब्झर्व करत असतो. While observing these two first two station concludes that some other stations are having the higher bit than us. ओके, सो ह्या पहिले दोन जे स्टेशन्स आहेत ते दोघं कन्क्लूड काय करतात की आपला फर्स्ट बिट काय झिरो आहे, पण झिरो पेक्षा हायर बिट असणारे अजून स्टेशन्स आहेत. सो इन दॅट केस these two station leaves the race. Okay, and these two station wins the race. Okay, means these two will be the out of race of acquiring the channel, and last two will be in a race for acquiring the channel. So after that, it means that these two are now, there should not be any operation. There should be a silent zone for these two. Now for the next slot, next bit time is taken for these two addresses 00. Again, they are having of same address bit, so the result is being calculated. Now next again third bit address is considered 0 and 1. So again this station will conclude that yes, some other station is again having the higher bit than us. So this station number 3 will out of the race, or 3 will leave the race. Now only one station will be there 1010, whose address is 1010. So the channel will be allocated for station number 4. Okay, in this way one by one every station will get an access of the channel. Okay, so once the station number 4 completes, okay, station number 4 completes, the next operations, so the same procedure will be followed on these three. Okay, so maybe station number 3 will get an access next, again station number 2 will get an access, and then station number 1. So likewise every station will get an access of a channel, so obviously each one will have access of a channel one by one, so there will not be any chance of collision in case of the binary countdown protocol. So these are the two protocols which comes under the category of the collision free protocol. Okay, remember. So if you have any doubt, you can ask. Otherwise, we'll move forward. Any doubt? No doubt. Okay. So the next part is the limited contention protocol. So limited contention protocol. So up till now, as I already revised in the same lecture, that we have seen two types of the methods, we can say, or two types of the protocols, to categorize the protocols. Okay, one category was related with the contention methods. Okay, for example, CSMA or Aloha, likewise. And one category was related with the collision free protocols. Or broadly, we can say that some protocols or some methods are having the strategies which are having, means where the chances of the collision are there, and some strategies are like where chances of the collision not there, that is collision free methods. So these are called as a, these are the two basic categories. So if we consider these two categories for all the protocols, okay, their performance is measured depending upon these two performance measures. Okay, सो हे जे सगळे जे आपण प्रोटोकॉल्स बघितलेले आहेत त्याचे परफॉर्मन्सेस ऑफ वर्किंग हे या दोन कॅटेगरीतून मेजर केले जाते. फर्स्ट वन इज द डिले ॲट लो लोड and second is the channel efficiency at high load. Now what is the meaning of this? Low load means what? There is only one channel and for that channel very few stations are there, 2 3 for example, and they want to access that one channel. In that case what should be the delay of accessing the channel? जिथं एकच चॅनेल आहे आणि ते चॅनेल ऍक्सेस करायला खूप थोडेसे स्टेशन्स आहेत, फॉर एक्झाम्पल 3 स्टेशन्स आहेत आणि अशा केस मध्ये पण प्रत्येक स्टेशनला किती वेळ वाट बघावी लागते. डिपेंडिंग अपॉन दॅट द परफॉर्मन्स ऑफ दॅट पर्टिक्युलर protocol can be measured. That is the first measure. Second is what? Channel efficiency at high load. Okay, one channel is there. To acquire that channel, number of stations are there, and still how they are working, whether they are efficient or not. Depending upon that, their performance can be measured. So these are the two performance measures which are used to conclude or to measure the performances of these methods. Are you understanding? Okay. What is the first performance measure? Delay at low load. What is the meaning of this particular word? Delay at low load means what? Only one channel is there, and to access that particular channel, very few stations are there. In such case, after how many time the channel is get allocated to the station, depending upon that, the performance is measured. And second is what? If suppose there is one channel and to acquire that channel, how number of stations are available, and in that case how the channel is working, depending upon that its efficiency is measured. So these are the two performance measures which are used to conclude the performance of all these methods or the protocols that we have already seen. Okay. Now when we consider these two performance measures, okay, for example, in low load, contention is preferable and methods like aloha and slotted aloha are feasible. Okay, if you consider this particular strategy. So in case of the low load, म्हणजे खूप थोडे stations आहेत. In that case, we have seen some of the protocols like aloha and slotted aloha. They are feasible, means they work properly. But if we increase the load, but as the load get increased, these type of the protocols or the contention protocols are not useful. Okay. Now suppose if we consider the second category, that is collision free protocol. So in case of the collision free protocols, if we increase the load, then also channel efficiency is improved. These are the two different cases. First मध्ये काय आहे की लो लोड आहे म्हणजे स्टेशन्स थोडेच आहेत, आणि सेकंड मध्ये काय आहे की इफ इन्क्रीज द लोड देन चॅनेल इफिशियन्सी इज इम्प्रूव्ड. याच्यामध्ये लो लोड असताना हे स्लॉटेड अलोहा आणि प्युअर अलोहा फिजिबल आहे. फक्त प्रॉब्लेम कधी होतो जर लोड इन्क्रीज केला तर. आणि कोलिजन फ्री मध्ये काय आहे की इफ इन्क्रीज द लोड देन ऑल्सो चॅनेल इफिशियन्सी इज इम्प्रूव्ड. Okay, so these are the two strategies. But now it will be feasible if we acquire the properties of both, whatever we have seen these two. Okay, so the properties of contention period as like aloha, slotted aloha, and the collision free protocols as like bitmap protocol or binary countdown protocol, it should be combined to get a better result. ओके, मीन्स वॉट, प्रत्येकाच्या जे दोन आपण पार्ट्स बघितलेले आहेत हे कंटेन्शन मेथड्स आणि कोलिजन फ्री मेथड्स, या प्रत्येकाला काहीतरी कॉन्स आहेत, काहीतरी ऍडव्हान्टेज डिसएडव्हान्टेजेस आहेत. ओके, सिमिलरली सो इट विल बी फिजिबल. काय असणार आहे फिजिबल? दोघांच्या पण ज्या बेस्ट प्रॉपर्टीज आहेत त्या कंबाईन करणं. ओके, So the properties of both contention and collision free protocols should be combined to get a better result. And such protocols are called as the limited contention protocols. Okay, where the properties are combined. Now how they works? So the new protocols like limited contention protocol, they uses contention at low load. This जर suppose खूप थोडे stations आहेत, so they will work as like aloha and slotted aloha, and collision free techniques at the high load. आणि ज्यावेळेस खूप सारे stations आहेत त्यावेळेस they will work like a collision free techniques as like bitmap protocols or the binary countdown protocol. So in both the cases, there will be a same protocol. No need to use the different protocol for different processes. Am I clear? To improve the efficiency. So such type of protocols are called as a limited contention protocols. Samajhe what is mean by the limited contention protocols? Yes or no? Hmm? How they will work? How they will work? So if very few stations are available to get an access of a channel, in that case they will work like a aloha or slotted aloha. With example I'll tell you. And if suppose there is high load available, means number of stations are available to acquire only one channel, in that case they will work like a collision free protocols or collision free techniques, right? So such protocols are called as a limited contention protocols. Am I clear what is meant by the limited contention protocols? Any doubt? Yes or no? Any doubt? No.
No, ma'am.
Okay. Okay, fine. So these are the limited contention protocol. Now just observe this figure. So whatever we have seen here, how they should work. Okay, limited contention protocol कसे वर्कआउट झाले पाहिजे, that is shown over here only in this. What? Yes,
No, ma'am,
anybody is
nothing. My
having
little
any?
bro is. No, ma'am.
Okay, fine. Okay. So, same strategy of working of limited contention protocol that is shown over here. So you can see this graph over here. Okay, what is given here? Number of ready stations means what? Those who want to set the frame, those who are ready to use the channel. So that is shown over here, and here is what? Probability of success means what? What is the probability of getting the access of a particular channel, that is shown over here. So what is the conclusion of this particular graph? Can anybody tell? When the probability is high and when it is low, when the probability is high and when it is low.
0 to 5 is high. After that, it is low.
Yes, 0 to 5 is high, after that it is low. It is okay. That is the readings of the graph. What is the conclusion? याच्यावरून काय conclude होतं? What is the conclusion of this? If we increase the number of stations, so the success of getting access of the channel will get reduced. Means to get an access of a channel, there must be very few stations. Right? Yes or no? What is the given? If there are low stations, बघा ना 0 to 5 मध्ये किंवा for example 3 and 4. When there are very few stations are available, then there is the probability of success is high. So as the stations are goes on increasing, it means that probability is goes on decreasing. Means स्टेशनचा चॅनेलचा ऍक्सेस मिळण्याची प्रोबॅबिलिटी काय होते, कमी कमी होत गेली. Okay, so that is given, shown over here. Now why I'm showing this graph is that because this limited contention protocols, these are working on the same strategy. ठीक आहे, आपण काय म्हणतो की हे काय लिमिटेड कंटेन्शन प्रोटोकॉल्स, they combine the properties of contention and collision free protocols, right? But how exactly they work? So they follow this strategy, means there must be very few stations to have a high success rate. Okay, but how? हे कसं होणार आहे? Obviously there will be a lots of stations, number of stations wants to access the channel. What if 25 stations wants to access the channel? Whether we leave it? No. There must be some strategy. Now how they work, that is shown over here. Okay. So limited contention protocols increase the efficiency of channel by decreasing amount of competition. That is what conclusion of this graph. Okay. Now on the same conclusion or on the same uh, line, they are working. Now how they work? So first, what is the strategy followed is that they first divide the stations into number of groups. Okay, now see here, suppose there are 8 stations are there, 1 2 8, 1 2 3 4 5 6 7 8. These are the stations. So what the strategy first followed is that number of stations are divided into number of groups. Okay, the groups are disjoint, means there is no restriction that every group will contain 1 2 station, nothing. The groups are formed by any category. So once they divide the groups, the members of the same group are permitted to compute for a particular slot or for a particular channel. For example, let's see this example. This is group number 0, 1 and 2, right? So once this division of the station is done, right? So the members from the group 0 are allowed to compute for the slot or for the channel which is given for this particular group only. They will not interfere for the other groups. ठीक आहे, सो याच्यामुळे काय झालं, instead of 8 channels, sorry 8 stations, okay, each one has to deal with only 3 stations, correct? So in this way, or by using this division, what will happen, there will be a low load on a channel. ओके, सो ग्रुप 0 साठी जे चॅनेल असेल त्याला काय असणार आहे टास्क, की फक्त तिघांना स्टेशन, ह्या 3 स्टेशनला चॅनेल अलोकेट करून द्यायचं, नॉट फॉर द 8. सिमिलरली for group number 1, that channel has to get allocation for these 2 stations only. Similarly for channel 2, that has to allocate the channel for only 3 stations. So what is done, instead of having the load of 8 stations, every channel will have a load of very few stations. So in this way, this protocols or the limited contention protocol works. Okay, now I'll show you one example, one type of example of this limited contention protocol. From that you will get understood. Okay, so this is one example we can say, or one protocol we can say, which comes under a limited contention protocol. So see here, so I'll explain this diagram one by one. Please pay attention, because from this diagram only you will get understood how this is working. Okay, diagram दिसते व्यवस्थित सगळ्यांना? Yes, it is a tree like, okay, so it is a tree like structure, huh? 0 1 2 3 4 5 6 and A B C D E F G H, whatever it is. Now it is called as an adaptive tree walk protocol. Okay, adaptive tree walk protocol. Now in this adaptive tree walk protocol, the stations or the nodes, these are arranged in a form of binary tree. What is meaning of binary tree? Do you know what is mean by the binary tree? Yes, binary means what? Each station or each node or anything should be get divided into exactly 2 parts. That is nothing but the binary. So you can see here, this 3 is divided into 2 parts, 4 is divided into 2 parts, like that. 2 is divided into 2 parts, 0 is divided into 2 parts. It can be anything. So binary means what? Exactly two divisions. That is called as a binary. Okay. So this in adaptive tree work protocol, the nodes are arranged. Nodes, or we can say these stations. These are arranged in the form of a binary tree structure. Okay, as like a binary tree. Now, in this particular diagram, the stations or the internal nodes we can say, for example, 0 to 6. Numbers we said now 0, 1, 2, 3, 4, 5, 6. So, this represents the groups. Remember, remember this example. Groups म्हणजे काय असणार आहे, stations म्हणजे काय असणार आहे. So in this particular diagram 0, 1, 2, 3, 4, 5, 6, they will represent a groups, representing the groups. And the leaf nodes means exact खालचे, एकदम last level, A, B, C, D, E, F, G, H, they are representing the stations. ठीक आहे. 0 to 6 काय आहेत, ग्रुप्स आहेत, आणि A to H काय आहेत, तर these are nothing but the stations. So how they are working, please pay attention. For example, initially all nodes means these all leaf nodes A to H, they are having the permission to compute for a channel. इनिशियली काय असणार आहे, या प्रत्येकाला ए टू एच पर्यंत प्रत्येकाला परमिशन काय असणार आहे की दे विल हॅव एन कॉम्पिटिशन टू ऍक्सेस अ चॅनल. Okay, now if any of this node get a success to acquire the channel, in that case that channel, or sorry, that station can transmit the frame. तर ह्यापैकी ए टू एच मधले इनिशियली काय असणार आहे, प्रत्येकाला परमिशन असेल की तुम्ही चॅनेलच्या ह्याच्यासाठी अक्वायर करण्यासाठी कॉम्पिटिशन मध्ये येऊ शकता, आणि ज्याला कुणाला चॅनेल अलोकेट होईल फर्स्ट टाइम, सो दॅट विल transmit the frame. So that is initial phase. Okay, it can transmit the frame. Suppose as all are having the permission to get an access of a channel, it may possible that in such case collision will occur. बरोबर आहे ना. कोलिजन कधी होतं, खूप सारे जण एकाच गोष्टीसाठी एकाच वेळेस ज्यावेळेस ऍक्सेस करायचा प्रयत्न करत असतात. सो हियर ऑल्सो A to H, they are trying to get an access of a channel at the same time. So it may possible that the collision will occur. If collision occurs, in that case, these particular channels A to H, these are divided into two groups. Okay. जर कोलिजन झालं तर काय करायचं, जेवढे चॅनेल्स आहेत ते काय करायचे, तर दोन ग्रुप्स मध्ये डिवाइड करायचे. फॉर एक्झाम्पल, फर्स्ट ग्रुप विल बी A, B, C, D, which will come under node 1, and E, F, G, H, which will come under group number 2. Group number 1 is what? A, B, C, D, and group number 2 will be E, F, G, H. This will be the true. हे कधी केलं? If collision is occur, then only. ठीक आहे. Now the nodes, okay, which are belonging to only one or only one of them is permitted for computing. For example, suppose slot number 1, all stations under group 1 are allowed to contain, or these are allowed to access the channel. राईट. नाव आता काय झालेलं आहे बघा, ग्रुप नंबर 1 मध्ये कुठले कुठले चॅनल आहेत, ए बी सी डी. ग्रुप नंबर 2 मध्ये आहेत ई एफ जी एच. नाव द सेम प्रोसिजर इन ग्रुप नंबर 1, ए बी सी डी will get an access, or they will be in competition to get an access of a channel, and in group number 2, E F G H will be in competition to get an access of a channel. Right. Now again, out of these four, if any channel gets an access, it will transmit. Similarly for this also. But suppose again, as these four are again competing at the same time, it may possible that collision will occur. Correct? Now, if collision occurs, then again this group is divided. बरोबर आहे. आता ग्रुप कुठला होता, 1 च्या अंडर ए बी सी डी होतं, 2 च्या अंडर ई एफ जी एच होतं. पण जर कोलिजन झालं तर काय, then if collision occurs, then what will happen, Again, these are divided into subgroups, right? Now, this division will be what? The group will be like some stations under 3. That is, A and B will be under 3, C and D will be under 4, E and F will be 5, G and H will be under 6. Correct? And now, again, same procedure. So, obviously, here the competition is low. Instead of having 8 or 4 stations, now there will be a channel which have to or get an access for only these two stations. Similarly, here. So likewise, unless and until each and every station will get an access to send a frame of a channel, this same procedure of dividing the stations into group is followed. Are you getting me? Yes or no? समजतंय? काय केलं? Same procedure like this. I have shown only one example over here. ते actual मध्ये कसं जातं? Okay, I'll repeat again. Please pay attention. Okay, so what is this example? This example is for the limited contention protocol, where we assume that instead of having lots of protocols to access one channel, it will be better that we should reduce the number of channels, sorry, number of stations. And this division is done as like grouping format, means every group will have certain amount of channel in it, certain amount of stations in it. Likewise, this grouping is done. Right now, by using the same strategy, this adaptive tree walk protocol works. How it works? So it is a tree like structure, or we can say a binary tree like structure, where this 0 to 6 represent the groups and A to H represent the number of stations. Okay, 0 to 6 are the groups and A to H are the number of stations. Right now, बायनरी मीन्स एक्झॅक्टली टू हाफ मध्ये प्रत्येक पार्ट डिवाइड झाला पाहिजे. सो दॅट इज नथिंग बट द बायनरी. नाउ फर्स्ट इनिशियल ॲट इनिशियल स्टेज every station, that is A, B, C, D up to H, every station is allowed to have a competition to get an access of a channel. Right? There will be two cases. Either any station will get an access of a channel, or collision will occur. So first case is what? Maybe any station will get an access of a channel. In that case, that station will send a frame. For example, this station, station D. D ला काय झालेलं आहे? Suppose channel मिळालं. Okay. So this station will send an frame. Okay. But हे सगळेजणच काय आहेत? एकाच वेळी कॉम्पिटिशन मध्ये आलेले आहेत. So it may possible that at that case collision is occurring. Collision होईल. So if collision occurs, then only the next part. जर collision झालं तर काय करायचं? If collision is occurred, these 8 protocols, sorry, these 8 stations, these are divided into groups. How the groups are formed? Now this group number 1 will have a 4 station A, B, C, D, and group number 2 will have a stations E, F, G, H. Right? Again the same procedure. In group number 1, 4 stations are there. They will again have a permission at initial stage to access the channel. So if any station gets an access, it will transfer. But again, if collision occurs, then again these are divided into next group level. Okay. So for example, group number 3 will have these two stations A and B. Group number 4 will have C and D. 5 will have E and F, and G will have, sorry, 6 will have a G and H. Okay, so the same strategy is followed unless and until every station will get an access of a channel. Okay, it is simple. So this adaptive tree walk protocol follows the strategy is what? There must be very low load to acquire the channel. Channel ला हे ऍक्सेस करण्यासाठी किंवा अक्वायर करण्यासाठी कॉम्पिटिशन थोडं पाहिजे. इन दॅट केस सक्सेस रेट विल बी हाय. दॅट इज व्हॉट वी हॅव सीन हिअर. Okay, so in this way adaptive tree work protocol works. समजलंय? Any doubt?
No, ma'am.
Everyone has understood?
Yes, ma'am. Understood.
Okay. Any other student is having doubt? Then maybe you can ask me. Yes, girls. Have you understood? Yes,
Yes, ma'am.
Amrita, Pooja, Pallavi, everyone.
Yes, ma'am.
Okay, no doubt. सगळं समजलं. श्रुती. Yes, roll number 1. Are you there?
Yes, ma'am. Yes, yes.
Okay. समजलं ना सगळ्यांना? बॉईज मध्ये. येस, ओम, अरबाज,
Yes, ma'am.
प्रतीक.
Understood.
Yes, ma'am.
ओके ओके. योगीराज देशपांडे.
Yes, ma'am.
Okay. So no doubt. So this is the one protocol which is there in which comes under a limited contention protocol. The next protocol is the wavelength division multiple access, okay, which is WDMA, wavelength division multiple access. Okay, so what is this protocol? We will see. So at the start of the chapter, we have seen the channel allocation problems. Two types of the channel allocation problem we have seen, right? So first one was the static channel allocation and second one was the dynamic channel allocation. Okay, static मध्ये FDM, TDM बघितलं होतं आणि डायनॅमिक मध्ये आपण रिमेनिंग स्ट्रॅटेजीज CSMA वगैरे बघितलेले होते, राईट? So in case of the wavelength division multiple access protocol, this uses the approaches of the FDM, TDM by using dynamic allocation. Okay, strategy of FDM and TDM is used there, but instead of static allocation, it uses the dynamic allocation. Okay, FDM means what? What is mean by the FDM or TDM? Can anybody tell? Frequency division multiplexing, how it was working in case of the static allocation problem that we have discussed. Yes, आठवते how the FDM was working? Hmm? No. Okay, I'll tell you what is mean by the FDM. So total frequency is divided among, or it is allocated among the number of stations. Suppose 4 stations are there. So whatever total frequency is there, that is equally divided among these 4 stations. So that is nothing but the FDM, and same strategy is followed by the TDM also in case of the static division multiplexing. But what we are going to see here is the here is the dynamic division, means strategy is same, that is the frequency is allocated among the different channel, but the number of channel or the quantity of the channel is not fixed, it is dynamically. If the channel gets added, then also frequency will be allocated. If it is deleted, then it will not get allocated, means there will not be any loss of the frequency. So in this strategy, depending upon this strategy, this particular protocol works. Okay, so we'll see. So different approaches are used here to allocate a channel to number of stations, as like dividing the channel into sub channels by using FDM, TDM or both. That is what I have explained now. So one such protocol which allows transmission at the same time using dividing wavelength into equal spectrum is wavelength division multiple access. Okay. The protocol which allows transmission at the same time is dynamically using dividing available wavelength. म्हणजे wavelength divide केली की ते assign करायची for a particular channel. So this protocol is called as a wavelength division multiple access protocol. Okay, let's see how it works. So this is the diagram for this WDMA. Okay, please pay attention for 5 minutes only. I'll cover the diagram only. Actual working it will take a lot of time. Actual मध्ये diagram मध्ये काय indicate केले that only I'll cover and then we will stop. Okay, so please pay attention. In next lecture I don't want to waste time for this part. Okay, so suppose there are four stations. So stations are given A, B, C, and D. There are four stations. So each station is having two channels. Okay, so you can see here. प्रत्येक स्टेशन दोन पार्ट मध्ये डिवाइड केलेलं 1 2 1 2 1 and 2. So every station is having every station is assigned two channels. First channel is provided as a control channel. First is provided as a control channel to the signal the station, and the second is provided for output of the data frame. Okay, now what is mean by the control channel and how the data frames are transmitted, I'll show you. So first one is what it is in control channel diagram मध्ये सांगितलेलं बघा. A is control channel, B is control channel, C is and D is control channel. And second one is what this particular second channel is used for transmission of the frame. Second channel कशासाठी होतं transmission साठी होतं. Now first we will see what is there in the control channel. So you can see here in the control channel in the first slot in the control channel, suppose there are m slots. Okay, m timing slots are given. Okay, m timing slots are there. In case of the data channel, there are n time slots and one extra slot is given for maintaining the status. Okay, maintaining the status. Now what is this status? It is nothing but it is what it records. So this station is used to report the status of a particular channel. For example, whether this channel is allocated or this slot is allocated by any other station, or whether it is free or not. So such type of status is recorded by this particular slot or by this particular status. Okay, so these two stations, what it does, first is what it contains m slots for controlling the frame or for controlling the connection between the number of stations, and the second one contains the slots for transferring the data. In that it will have a n slots for the data and one extra slot is given to maintain the status of a station. ठीक आहे, स्टेटस ऑफ अ स्टेशन म्हणजे काय समजलं, ते स्लॉट फ्री आहे का, तिथं कुठला डेटा ऑलरेडी अवेलेबल आहे, ते पर्टिक्युलर स्टेशन दुसऱ्या कुठल्या तरी चॅनल सोबत ऑक्युपाइड झालंय का नाही. सो एव्हरीथिंग that is maintained by this particular status. Okay, now I'll show you a short example of this working, how these two are working. Okay, for example, consider these two stations, station A and B. These are the two stations and there is a connection oriented service provided between the A and B. दोघांच्या मध्ये कम्युनिकेशन कसं होते, डिपेंडेंट अपॉन कनेक्शन ओरिएंटेड सर्व्हिस. Right, now for example, suppose station A wants to communicate with the station B. Station A wants to communicate with the station B. In that case, station A has to insert a connection request frame in a free slot on B's control channel. जर सपोज A ला B सोबत कम्युनिकेट करायचं, तर A स्टेशन काय करतो, तर एक रिक्वेस्ट सेंड करतो कोणाला, B ला. कनेक्शन रिक्वेस्ट एस्टॅब्लिश करतो. कुठे एस्टॅब्लिश करतो? इन द कंट्रोल चॅनेल ऑफ बी, म्हणजे इथं. Right? So you can understood what is the use of this B's control channel. Now suppose B accepts this request. B काय करते की ओके कनेक्शन हे कम्युनिकेशन करायचंय ए ला आपल्यासोबत. सो सपोज बी ने काय केलं? ऍक्सेप्ट केले रिक्वेस्ट. इन दॅट केस कम्युनिकेशन कॅन टेक्स प्लेस इन एज डेटा चॅनेल. राईट? सो ह्या दोघांच्या मध्ये काय होणार? तर कम्युनिकेशन होणार. कसं होणार? इन दिस पोर्शन हियर मीन्स कम्युनिकेशन होणार म्हणजे काय? फ्रेम सेंड होतील किंवा रिसिव्ह होतील. सो ए ला जर बी शी कम्युनिकेट करायचं असेल तर काय करतो? ए फर्स्ट काय करतो? रिक्वेस्ट सेंड करतो. कोणाला? बी ला. ती रिक्वेस्ट कुठं असणार आहे? कंट्रोल चॅनेल मध्ये बी च्या. जर सपोज बी ने रिक्वेस्ट ऍक्सेप्ट केली तर काय होणार आहे? या दोघांच्या मध्ये कम्युनिकेशन होईल. पण ते कम्युनिकेशन कुठं होणार आहे? तर ए च्या डेटा पार्ट मध्ये, ऍट दिस पार्ट. सिमिलरली सपोज बी वॉन्ट टू कम्युनिकेट विथ ए. आता काय करायचं? बी ला ए शी कम्युनिकेट करायचं. सो व्हॉट इट विल डू? इट विल एस्टॅब्लिश अ कनेक्शन विथ ए बाय युजिंग दिस slot. If suppose A accepts the request, then transmission or the communication will happen in B's data slot. Right? In that case, what this S will contain? This S will contain that B is communicating with A. It means that B is now occupied. It is not free. In suppose same time ला जर C ला पण B शी communicate करायचं असेल, so this status will indicate that B is busy with A. So C has to wait. Okay. So this is how this particular protocol works. That is wavelength division, multiple access. Okay. So there are lots of things that there in the same protocol. So for now, I will stop here. I'll share this PPT for today of today's lecture. You please understood this diagram because ह्या diagram वरती पुढे खूप सारे explanation मला उद्याच्या lecture ला तुम्हाला सांगायचंय. So you should understood the working of this diagram. सिंपल आहे. प्रत्येक स्टेशनचे दोन पार्ट्स असणार आहेत. ठीक आहे. फर्स्ट मध्ये असणार आहे चॅनेलचा कंट्रोल, सेकंड मध्ये असणार आहे डेटा फ्रेम. चॅनेलचा कंट्रोल मध्ये जे असणार आहे ते काय असणार आहे? टाइम स्लॉट्स असणार आहे. आणि डेटा स्लॉट मध्ये काय असणार आहे? डेटा थोडेफार स्लॉट असतील ते डेटासाठी आणि एक स्लॉट असेल तो स्टेटस साठी असेल. ठीक आहे. जर सपोज कनेक्शन करायचं असेल किंवा कम्युनिकेशन दोघांना करायचं असेल तर ते काय करणार? फर्स्ट कनेक्शन एस्टॅब्लिश करतील आणि कनेक्शन झाल्यानंतर ते एकमेकांच्या सोबत कम्युनिकेट करतील. कम्युनिकेट करतील म्हणजे फ्रेम सेंड करतील. मग फ्रेम सेंड करताना हा पार्ट यूज होईल. कनेक्शन एस्टॅब्लिश करताना हा पार्ट यूज होईल. बट वेन टू यूज प्लीज रिमेंबर. ए ला बी सोबत कनेक्शन करायचं असेल तर तो काय करेल? बी च्या कंट्रोल चॅनेल मध्ये कनेक्शन एस्टॅब्लिश करेल आणि कनेक्शन एस्टॅब्लिश झाल्यानंतर बी कम्युनिकेट करताना ए चा डेटा चॅनेल यूज करेल. करेक्ट? So this is how it works. Okay. So we will stop here. In next lecture, we will continue with the same point. Okay. Any doubt up to this? I'll share this PPT with you. Please read once. Adaptive tree walk पर्यंत problem नसेल. I hope so. Okay. So I think it is clear. So next lecture again I'll repeat the wavelength division multiple access. That it will get clear. Any doubt? Yes, any doubt? I hope no doubt. Okay, so we will stop here.